back. The problem here is position of a particle is given by this function. Find the velocity then find the velocity after 2 seconds, after 4 seconds. When is the particle at rest? When is the particle moving forward? Okay. Draw a diagram to represent the motion of the particle. Find the total distance traveled by the particle during the first 5 seconds. Find the acceleration at time t and after 4 seconds. Graph the position, velocity, and acceleration from 0 to 5. When is the particle speeding up? When is the particle slowing down? A lot of questions. Let's go through them one by one. This is your position function, S. Velocity is the derivative. 3t squared minus 12t plus 9. After 2 seconds, we are going to plug in t equals 2 in the velocity function. So I have written down the velocity function on the side for us, right? That is the derivative. All right. Now after 2 seconds, we are just plugging in t equals 2. That gets me negative 3 meters per second. What does that mean? Negative 3 means I am moving back. What is the velocity after 4 seconds? 4 seconds, we are plugging in 4 for t in the velocity function, 4 for t. And you get 9 meters per second. That is, you are moving forward. When is the particle at rest? Particle is at rest when the velocity is 0. You see, you are driving. When you stop, velocity is 0, right? So, velocity is 0. Velocity is this function. So, that function has to be 0. Let's factor it. 3 is common. All that happens. This factors further. In other words, when t is 1 or t is 3, velocity is 0. So t is 1 or t is 3, velocity is 0. So the particle is at rest after 1 second and after 3 seconds. So, next question. When is the particle moving in the positive direction? Well, particle moves in the positive direction when velocity is greater than 0. What is the velocity function? Velocity function was all this. That has to be greater than 0. But we just factored it. When you factor it, you get 3 t minus 1, t minus 3. Remember the factorization? When is that greater than 0? Well, you might want to graph it, by the way, okay, to understand it better. So I'll come to that. Let's graph it. If you recognize this, this is actually parabola. Okay, so what is the parabola function? It has, instead of t, I'm using x, okay, because I'm x and y axis. 3x squared minus 12x plus 9. So this is a parabola, if you notice. So that, by the way, was the velocity function. Notice how at 1 and 3 velocity is 0. Between 1 and 3 velocity is negative. To the left of 1 velocity is positive. To the right of 3 velocity is positive. Okay, that's all they are saying. Velocity is positive to the right of 3 and to the left of 1. Okay, and between 1 and 3, velocity is negative. So, in other words, beyond 3 and beyond 1, because my velocity is positive, my particle is moving forward. between 1 and 3, because the velocity is negative, between 1 and 3 my velocity is negative, my particle is moving backward. So velocity is positive, negative infinity to 1, union 3 to infinity. Velocity is negative between 1 and 3. So this, when velocity is positive, mind you, when velocity is positive, you get particle is moving forward. Here, when velocity is negative, particle is moving backward. All right. I hope you can read it clearly. All right. So, moves backward between 1 and 3. In other words, one more thing I want to point out. Time cannot be negative infinity. All right. Time cannot be negative, basically. So, I rewrite this interval as 0 to 1 and 3 to 8. So, time between 0 and 1, my particle is moving forward. After 3, particle moves forward. Between 1 and 3, particle is moving backward. Exactly the picture here, right? Between 0 and 1, let's see, right? Between 0 and 1, particle is moving forward. 3 and infinity, when time is 3 seconds, particle is moving forward. But between time 1 and 3 seconds, particle is moving back. That's the picture you need to draw. Okay? Let's keep that picture in mind. Here. Okay? 0 and 1, you're moving forward. 1 and 3, you're moving backward. After 3, you're moving forward. All right, so we have all this information. Okay? So, what about the distance, total distance traveled in the first 5 seconds? So this is time t equals 3 seconds. Somewhere here it's 5 seconds. I don't know where. All right, it doesn't matter. The point is, I don't want forward and backward to be cancelled each other. It is, after all, a total distance. So total distance is different from displacement. Okay? Distance is the actual distance you've covered, whereas displacement is the change in location. Okay? For example, if I take from time t equals 0 to time t equals 3, my displacement is 0, because however much I've moved forward, I moved behind also. So displacement is 0. But distance, I did cover some distance, right? So you have to be careful. So distance traveled in the first 1 second is position at 1 second minus position at 0, that is 4 meters. So from here to here is 4 meters. Then time 1 to time 3 is 4. So this is distance at 1 and distance at 3 seconds. You're back, but the distance covered is 4 again. All right, that's why you have absolute value. Distance takes care of only positives. 3 to 5, you're looking at position at 5 minus position at 3 and taking absolute value. That's 20. So in all, you covered 28 meters in the first 5 seconds. What about the acceleration? Acceleration is second derivative of position or derivative of velocity. Let's look at the velocity. Velocity was this. Its derivative is 60 minus 12. After 4 seconds, well, I'm just plugging in t equals 4. Now, graphs of S, V, and T. S is the pink one. V is the parabola, A is the line. Okay, so they have used a computer system to graph these, which is fine. Lastly, here is the tricky one. Particle speeds up. Particle speeds up when velocity is positive and increasing. Not only are you moving forward, your velocity is also increasing. That is, both V and A has to be positive. On the other hand, if I'm moving back and my rate of change is my velocity is decreasing, then also I'm speeding up, because not only am I negative, I'm going back, but I'm going slower back. In other words, two negatives. All right. Particle speeds up when velocity and acceleration have the same sign. Let's look at the picture here. Velocity is the parabola. Acceleration is the straight line. So if you notice over here, here to here, both acceleration and velocity are negative. All right. And here onwards, both acceleration and velocity are positive. So this interval and this point onwards. So 1 to 2 and 3 onwards. Okay. So V and A have opposite signs between 0 to 1 and 2 to 3. All right. So that's when they slow down. Okay. So the particle is speeding up 1 to 2 and greater than 3, whereas slowing down in the leftover intervals 0 to 1 and 2 to 3. All right. So that completes problem example 1. We will come to example 2 in the next video. Until then,